Okay, for today's assignment, what you're going to be doing is I'm going to give you a choice. If you can't find the materials or whatever at home, I don't want you to have to spend like 6 hours trying to get this done and go to the store and stuff like that. I guess you can go to the store if you'd like, but you got your choice. You can either do the three-dimensional model for 5 points, or you can do a two-dimensional poster or drawing that you can show me for 4 points. Okay, so for the full 5 points, I want it to be three-dimensional. Now, the materials you can use, I don't know, I guess you could draw the pictures or whatever. The basic idea here is I want you to become familiar with the structure, basic structure of the sun, earth, moon system. Okay? You got to have certain characteristics that have to happen in your model, which could be, like I said, three-dimensional or two-dimensional. The sun needs to be bigger than the earth, and the earth needs to be bigger than the moon. We're going to be getting into accurate scale next time, okay? But for now, most of the pictures you'll see in an astronomy book are way out of scale. And so for this assignment, I'm not going to insist that you try to make something to scale. Okay, so like you can have the sun, and then the earth, and then the moon going around it. Now, if you do it as a poster, make sure they go counterclockwise, because that is the way that things go in the solar system is counterclockwise. And the reason for that is the second hand on a clock goes clockwise because of because that's the way the shadows move on the Earth from a sundial, and it does that because the Earth is rotating counterclockwise. All right, if you didn't follow that, don't worry about it. But when you're drawing, make it counterclockwise. So if you're going to be doing a three-dimensional model, like I said, you can make it of whatever materials you choose. Now, here's I got done so far is the Earth and the moon. Okay. Now the tricky part is getting it balanced. This is called making a mobile or a mobile sculpture, right? And so goes around the moon, goes around the Earth, and so structurally, that's what you want to have is the moon going around the Earth, and that the Earth is larger than the moon. Okay. Now I'm going to expand this to include the sun. So I'm going to have to get a second rod to attach to that. So this whole thing will go around the sun. And for the sun, I've got a marble and like actually it's kind of like a tennis ball, but it's, a dog ball. And then I got another kind of dog kickball. It's a little bigger. That's going to be my sun. Okay, so now I'm going to attach these guys, with another wire so that the Earth Moon system will go around. I'll show you that in a second after I attach it. So hang on. Okay, so now I have another wire. Now what I used is just a wire coat hanger that I snipped it to be to size. You could use a wooden dowel or whatever you have that's handy. And so now the tricky part for the next business, you can see how the moon goes around the sun, right? And then the sun and the moon need to go around there. So make sure you got to tape it so the string doesn't slide. If the string's sliding around, it won't work. And now what I got to find is the balance point is right there. See where my thumb is? That's where I got to attach the next piece of string so the whole thing can hang, right? And so I'll be right back after I get that done. Okay, now I have this hooked until it hangs. So what we have now is a mobile sculpture. I could hang it from somewhere in my room if I wanted to. And then the Earth is going around the sun, and the moon is going around the Earth. And what this does is it's a model that you made that shows the basic structure of the sun, earth, moon system. Now, there's a couple of concepts that are kind of important here. Where I have this attached, this is sometimes called the balance point, but really what it's called is the center of mass. That means that you have leverage working on it here. Even though this weighs more, since it's moved over on this side, the leverage means that this would be the center of gravity would be right there for this system, right? There's equal amount of mass on that side as on that side if you account for the leverage from it being further out. Okay, so that's a concept that will come up again in physical science. So I think it's a kind of nice one to have now. So your assignment is to try to make a mobile sculpture of the sun, earth, moon system. The key ideas are that the sun is larger than the earth is larger than the moon goes around the earth, and the Earth-Moon system goes around the sun, okay? That's your goal. If you can't get the materials together and figure out how to make something like this three-dimensional, you can do it two-dimensional with the drawing to show the same sculpture. Something similar to like what I have in the background there, or like I'm going to have in the little video segment. Keep in mind the scale on this is that's what the next lesson is going to be about, is what would the accurate scale be for it to be the earth is proportionally the right size in your mobile sculpture. So I'm not going to make my lesson explanation all that long because I want you to spend the time making the thing. All right, there's your assignment. Go for it. And I want you to videotape yourself showing the sculpture to turn it in. All right. Or your poster. When you show me the poster, by the way, don't just go, here it is, boom. Hold it up enough and explain it a little bit. Okay? Thank you very much. And I look forward to seeing these. Oh, one more important thing. Part of the fun of this and the part that makes it really intellectually interesting to do is the process of being creative, right? Of trying to find materials that would work for this. You can be creative. It doesn't have to be, I just happen to use a couple of dog toys and a marble for the moon is what I use. But if you have some other things that you think would work for relative size, be creative, be inventive. That kind of, in some sense, the more clever you are, the more I'll enjoy it. And that would actually help, I think, a little bit for me to give it a good grade because I like creativity and inventiveness. All right, so I look forward to seeing what you got. Try to have this done by next class period if you possibly can. If you need a little extension on time, that'll be fine. I'll give you a week, okay? But try to get it done by the next lesson, okay? But again, if, oh no, I can't get it done by then you don't have to ask permission. Just, give yourself an extra few days, okay? So I'm not going to count them late, but just make sure you get them done. All right. See you.